Welcome back, everyone. In this lecture, we're going to have a quick overview of the exercises for this section of the course. Let's head over to the exercise notebook. All right, here we are at the exercise notebook. For these exercises, we're going to be working with the Fashion MNIST dataset, also available through TorchVision. And just like MNIST, it consists of 60,000 examples for the training set and a test set of 10,000 examples, where each example is a 28 by 28 grayscale image. And there's a total of 10 classes. However, instead of being handwritten digits, they are different articles of clothing, such as a pullover, a dress, a coat, shirt, etc. So, at the very top, we already have a cell pre-filled in for you, which has the imports and also loads in the data set. So you don't need to worry about that. Go ahead and just run this first cell. It'll put any imports that you need for this exercise, and then we'll also load in and transform the data for you, as well as set up the class names in the correct order for you. So we have that ready to go. Then your first task is to create data loaders to create a training loader object and a test loader object with batch sizes of 10. Then examine a batch of images. So go ahead and display a batch of images like this, and optionally, you can display it along with the numeric label and the string label or string class. Then we have a couple of questions for you, and these are just meant for you to kind of think about, maybe do a little bit of math on the side. But the first question is, if a 28 by 28 image is passed through a convolutional layer using a 5 by 5 filter, a step size of 1, and no padding, what is the resulting matrix size? So see if you can calculate this one either by hand or in a new cell. And when you're ready to check the answer, you can run this cell here to check your answer. Then, also kind of a handwritten question is, if the sample from question 3 is passed through a 2 by 2 max pooling layer, what is the resulting matrix size? And this is a 2 by 2 max pooling layer with a stride of 2. And then you can run this cell if you want to check your answer. After that, we'll move back to the coding section. We want you to define a convolutional neural network. We kind of filled in some portions of it here for you, and we set up a manual seed. But go ahead and fill this in. The model should contain 2 convolutional layers, 2 pooling layers, and 2 fully connected layers. And we'll give you free reign to use any number of neurons per layer you want. And if you're kind of stuck as far as what values to choose, go ahead and take a look at our MNIST dataset convolutional network. After that, we have a couple of more questions. So trainable parameters, what's the total number of trainable parameters, weights, and biases in the model? Recall that we've been able to show that before. Next, we want you to define a loss function optimizer. After that, go ahead and train the model for 5 epochs. Then evaluate the model and get some sort of test accuracy report out. Okay, so that's it. I'll see you at the next lecture where we go over the solutions.